Hello everyone, welcome to the next lecture of quantum computing. In previous lecture we have seen that how the bond rule works, how we are going to calculate the probabilities using the bond rule. Now in this lecture we are going to explore the single qubit. Now imagine a coin spinning in the air. It's not head, not tail. It is in a both position at the same time, full of potential. That's what qubit is in the quantum world. A state of the infinite possibilities until we measure it. So let's break down this. A qubit or the quantum bit is the smallest unit of the quantum information, same as in the classical computing. uh, 0 and 1 is the smallest bit of the classical information. In quantum, a qubit is the smallest unit of the quantum information. So, uh, as we know that in classical computing, we can use either 0 or either 1. But in a quantum computing, we can use the qubit, which is a superposition of 0 and 1, right? So, mathematically, when we are showing the qubit, so it looks like kate q is equal to alpha kate 0 plus beta kate 1, where alpha and beta belongs to the complex, right? So this is the equation for the qubit, where 0 and 1 are the orthonormal basis. These are the orthonormal basis state whose inner product is 0. We have seen in a previous lectures that the inner product of the 0 and 1 is 0. Means when we are taking the inner product, suppose we will take the inner product of 0 and 1. We have solved this problem. So if I will put the value of 0, that is a 1 0, and 1, that is a 0 1. If we will multiply this, we are getting the output as a 0. So when this situation is happened, that is known as a unorthonormal state. So when we are taking the inner product of two different vectors, we are getting the output as a 0. So this is nothing but the orthonormal state. Then what is a Q? So Q is a column vector of the alpha beta, that is a column matrix alpha beta. The qubit probabilities collapses to the state basis. Now we have already learned the bond rule, so we will quickly revise that. So what is the probability of getting a Kate 0? Here I have written probability of q is equal to 0 is equal to inner product of 0 and q modulus square. So if we will solve this equation, you can see over here I have solved this equation. Bra 0 multiplied by equation of qubit. What is the equation of qubit? Alpha kate 0 plus beta kate 1. So if we will solve this equation, we are getting alpha into inner product of 0 0, then plus beta into inner product of 0 1, modulus of square. So as we know that the inner product of same vector is equal to 1 and inner product of different vector is equal to 0. So it will replace by 1, it is replaced by 0. So what will be the answer? Alpha into 1 plus beta into 0. So we are getting the answer alpha. So the solution for this is modulus of alpha square that we have seen in the bond rule. Using the bond rule, we have calculated the probability, right? Similarly, now we will calculate the probability of getting kate 1. Means the vector q, that is a qubit q, is equal to the kate 1. So to do that, we will use the bond rule. So inner product of 1 and q modulus of square. We will solve this equation. After solving this, we are getting the beta square. So here we have proved that probability of getting Ket 0 is a alpha square, probability of getting Ket 1 is a beta square. Now this alpha square plus beta square is equal to 1. How this alpha square and beta square is equal to 1? To understand this, we will take one small example. Suppose, so to understand this, suppose I have taken one example. Ket psi is equal to 1 by root 2 of Ket 0 plus I by root 2 of Ket 1. So this is the equation of my qubit. Now I will calculate that probability of getting sorry, probability that psi is equal to Ket 0 is equal to what we need to do? Inner product of 0 and psi. So if we will solve this equation, we will be getting 1 by root 2 modulus of square, which is a value 1 by 2, right? Similarly, if we will calculate the probability of Ket psi is equal to Ket 1, so we will get the value 1 by root 2 modulus of square, which we will give the answer 1 by 2. So if we will add this value 1 by 2 plus 1 by 2, we will get the value 1. So this is how we are getting alpha square plus beta square is equal to 1. So this is all about the qubit. Now we will move forward to the qubit representation. Now how to represent the qubit. In previous lecture we have discussed that qubit is represented in the Hilbert space, right? So in the Hilbert set, how it look like? So this is an Bloch sphere. You can see the Bloch sphere over here. Bloch is a scientist who has invented this Bloch sphere. So have you ever looked at the globe and thought about how every point represents a possible place on our Earth? Well, the Bloch sphere is look like a globe for the qubit. It's a 3D representation where every point on a surface correspond to the unit qubit state. So let us discuss this Bloch sphere in a deep. So firstly we will see what is a Bloch sphere. So on the screen you can see the graphical representation of the Bloch sphere. So in this graphical representation you can see that Ket 0 is represented on the z-axis and this is a x-axis, then this is a y-axis, and Ket 1 is represented negative of the z-axis. So this is a complete representation of a Bloch sphere. Now we will understand how the qubit is represented in a Bloch sphere. So to represent the qubit, as we know that qubit is equal to alpha of Ket 0 plus beta of Ket 1. Suppose I have drawn a qubit near to the x-axis. So as you can see graphical representation, this is a qubit which is given by the equation alpha Ket 0 plus beta Ket 1. Now here the value of alpha is r1 e raised to I theta 1 and beta is r2 e raised to I theta 2. Now what are the values of r1 and r2? So r1 and r2 are independent of the theta and which is giving us the value r1 square plus r2 square is equal to 1, which is a normalized state where the value of r1 is cos theta by 2, and value of R2 is a sine theta by 2, where theta is the angle between the qubit and a basis vector. Now here see basis vector, this z axis is a basis vector. When I'm saying that this qubit is on the basis of 0 and 1s, that means I'm calculating the angle between the qubit and the angle between the qubit and z axis for the calculation of this qubit. If I am saying that this qubit, if I want to write, suppose I will take one another example, qubit q is equal to 1 by root 2. Suppose I will take a phi plus ket phi plus 1 by root 2 ket psi. What it means that I am calculating the qubit on the basis of phi and psi, right? So this is all about the qubit. So here the value of R1 is cos theta by 2, value of R2 is a sin theta by 2. So theta is the angle between the qubit and basis vector, which is a twice as larger as a Hilbert space. Then theta 2 is given by the formula theta 1 plus phi. Phi is a relative phase. What is a relative phase? Relative phase, relative phase means suppose I am taking the basis state as a uh, z axis. So if I am taking a basis state as a z axis, so projection of the vector q is my projection of vector q, and the angle between the projection of vector q and the z axis is given by the phi. That is a relative phase. So qubit relative phase is given by the phi. So using this expression we will see that what are the values of gate 0, gate 1, and what are the values of qubit lying on the x-axis and y-axis. So firstly, the value of gate 0, as we know that it is denoted by the matrix, that is a column matrix 1 0. Then value of gate 1 is denoted by the column matrix, that is a 0 1. Now to calculate the vector on the lies on the x-axis. So when the vector is lies on the x-axis, so firstly we will calculate it. So to calculate it, from previous discussion we found that the qubit q is given by the equation cos theta by 2 gate 0, sorry, cos theta by 2 gate 0 plus sin theta by 2 gate 1, and here one multiplication factor, that is a e raised to I phi. So in previous slide we have seen this equation how this is formed. Q is equal to R1, Q is equal to, here we have seen that q is equal to alpha ket 0 plus beta ket 1. So here the value of alpha is r1 into e raised to theta, e raised to I theta 1, and beta is equal to r2, r2 into e raised to I theta 2. So from after solving this we are getting this equation. Same equation I have written over here. So to calculate the qubit which is lies on the x-axis, so we will put the values of the of that. So to put the values of that, here theta is given by the angle between the state vector and the basis states. So here basis state is a 0 and 1, so that means I need to calculate the angle between the z axis and this qubit lies on the x axis. So we will be getting the theta is equal to pi by 2, right? Then I need to find out the phi. Phi is equal to, phi is what? It is a relative phase. So it is a projection of, phi is a projection of state vector onto the xy plane and x-axis. So if we will see the projection of this qubit in a xy plane gives us the same line on the x-axis. So if we will calculate the angle between the x-axis and that projection, we will get it 0. If you will put the values of theta and phi over here, we will get cos pi by 4 k 0 plus e raised to I into 0 is 0. So I into 0 is 0 into sine pi by 4. Wait a minute. Sine pi by 4 gate 1. So what is the value of cos pi by 4? The value of cos pi by 4 is 1 by root 2. So we will get the value of this qubit is 1 by root 2 gate 0 plus 1 by root 2 gate 1. And this vector is known as a gate plus in a quantum. So here we have calculated the value of gate plus. So I hope you understand that how to calculate the qubit, how to calculate the value of qubit or equation of qubit. Here we have calculated the gate plus. Now after this we will calculate the value of qubit which lies on x-axis over here. Okay, so this vector is known as a gate minus. Now we need to calculate as we have calculated the gate plus. So for this gate minus, we have the values theta is equal to pi by 2 and phi is equal to pi. So when we will put this in the equation of qubit, so what we will get? So cos pi by 4 gate 0 into e raised to I pi into sine pi by 4 gate 1. So value of cos pi by 4 is 1 by root 2 gate 0. Value of e raised to I pi is minus 1 into sine pi by 4 is 1 by root 2 gate 1. So from here we have got the equation for the gate minus. I hope from this two example you understood that how to calculate the qubit equation. So we will see the next, we will see these equations. So as we have calculated the equation for gate plus, it is giving 1 by root 2 gate 0 plus 1 by root 2 gate 1. In matrix format, it is shown as a column matrix 1 by root 2, 1 by root 2. Then we have calculated the equation for the gate minus which lies on the x-axis. So for the gate minus equation is 1 by root 2 gate 0 minus 1 by root 2 gate 1. So it is giving us a column matrix. Values are 1 by root 2 and minus 1 by root 2. Then what about the qubit lies on the y-axis. So for the y-axis, the values of the theta and it's just a minute. So value of theta for k plus is given by pi by 2 and phi is equal to pi by 2. So if we will put these values, we will get the equation as you can see cos theta by 2, that is a cos pi by 4. The value of cos pi by 4 is 1 by root 2. So 1 by root 2 k 0 plus e raised to I pi by 2. So e raised to I pi by 2 value is I. Then sine pi by 4 value is 1 by root 2. So we are getting the equation 1 by root 2 k 0 plus I k to 1, which will give us this equation. Then similarly, if we will calculate the value of qubit lies on the y-axis this side. So to calculate that, we have a value of theta is pi by 2. So value of theta for k minus is pi by 2 and phi is minus pi by 2. So it will give us the equation 1 by root 2 k 0 minus I of k 1. So I hope you have understand how to calculate the qubit equation from this slide and from the Bloch sphere. So we will end the session over here. Do the practice of this qubit equation. It will help you in the quantum circuit. I hope you have understand all the concepts of the qubit, how to calculate the equation for the qubit. In next session, we will move forward to the quantum circuits. So thank you all of you. And if you have any question, you can post it.